Hello dear students, welcome to CAS Digital Classes. Today's topic is esterification reaction. Esterification reaction, as the name itself suggests, that there is a formation of ester. Esters are special compounds with C double bond O and O. That means COO groups, RCOOR. They are generally named as RCOOR. So these esters, this reaction is one of the important reactions in organic chemistry. Let us get into the details of it. So to understand esterification reaction, we need to know about how are they formed first. Esters are generally formed from alcohols. Alcohols and acids together form esters. Now, to understand the whole details of the reaction, we should know about alcohols specially. Alcohols are organic compounds which contain OH as the functional group, ROH. Simple representation of an alcohol. Now these are slightly acidic in nature because this ROH gives out a proton and an alkoxide ion. So as there is a release of proton, these are slightly acidic in nature. Now these may be aliphatic or aromatic depending upon the groups attached. So these alcohols can be synthesized from esters, acids, halides, ethers, carbonyl compounds, etc. From many compounds, alcohols can be formed. So based on the number of hydroxy groups and types of carbon chain attached, alcohols are classified into two types. Now we see the types of alcohols here. So this alcohol is an aliphatic alcohol because this is a straight chain compound, aliphatic alcohol, and the name is 1-propanol. So here number of hydroxy groups are 2. Here only one hydroxy group is present. In this compound there are 2 hydroxy groups, hence the name 1,2-ethane diol. So alls, diols, and this is also a diol, propane diol, 1,3-propane diol. Here, as there are 3 hydroxy groups, 1,2,3-propane triol, and one more 1,2,3-butane triol. So these are according to the attachment of carbon chain. We have primary, secondary, and tertiary alcohols. So primary alcohols, the functional group carbon, alpha carbon, is attached to only single carbon atom. Like here, this is a carbon, it is attached to only one carbon. Such compounds are called primary compounds, primary ethanol or ethanol. Now here, in this compound, the functional group carbon is attached to 2 other carbons. Hence, it is secondary. Whereas here, in this compound, we have 3 alkyl groups attached to 1 functional group carbon. Hence, this is a tertiary alcohol. Aromatic alcohol. Now, these are all straight chain compounds. Above all are straight chain compounds. Hence, these are called as aliphatic alcohols. Aliphatic alcohols. Now, aliphatic alcohols, if the groups are aromatic, then the alcohol becomes aromatic alcohols. Now, here this is phenol. We all know phenol. This is catechol because the number of hydroxyl groups are 2 catechol. And here there are 3 hydroxyl groups. This is pyrogallol. This is called as pyrogallol. Now, coming to the esterification reaction, that is about introduction of alcohols. Now, coming to the reaction, esterification. So, the reaction between excess of alcohol and carboxylic acid in the presence of mineral acid catalyst. Mineral acids means like HCl, H2SO4. These are mineral acids or inorganic acids. So, the product formed is esters. This reaction is called as esterification reaction. So, this was discovered by Emil Fischer in 1895. Hence, it is also called as Fischer esterification reaction. So here, this reaction is slow and reversible. So the reaction formed between excess of alcohol and carboxylic acid is slow reaction and also reversible. And the equilibrium, as it is reversible, the equilibrium is controlled by the ester that is formed at the end of the reaction. If any of the reactants, that means alcohol and carboxylic acid, if any one of them is taken in excess, we get high yield of ester. The product formed will be in high amounts. But the basic disadvantage of this reaction is reversibility. As it is reversible, sometimes the yield of ester cannot be managed properly. So to avoid that disadvantage, we synthesize ester from acid chlorides also. Now this reaction is irreversible, so there is no disadvantage of reversibility. And the amount of product formed, ester formed, is also high. Now this is the general reaction of esterification. As you can see, this is an acid carboxylic acid, this is an alcohol, and in presence of acid catalyst, we get an ester, R C double bond O O R, and H2O is also formed. Let us know the mechanism of this reaction. Here, first, the acid in presence of acid catalyst, carboxylic acid in presence of mineral acid, the carbonyl oxygen, as acid also contains carbonyl group, C double bond O group, the carbonyl oxygen will be protonated so that there is an oxonium ion formed. Now this delocalizes in resonance, undergoes resonance, and there is one more type of structure formed here with two hydroxy groups. And this carbocation formed here is attacked by the alcohol. That means the lone pair on oxygen will be donated to the carbocation. This gives a intermediate like this. But again, there is an oxonium ion formed because this lone pair has been donated to the carbocation. So after this, there is a delocalization of bond. This bond electron is transferred to the oxygen as this is highly electronegative and unstable. So, and the lone pair present here on another oxygen, another hydroxyl group will be transferred to the hydrogen atom. Now then, there is removal of water molecule here, and the lone pair on another oxygen atom, another hydroxy group on oxygen on another hydroxyl group gets transferred onto between carbon and oxygen to give a double bond. Removal of water, a double bond is formed along with hydrogen attached to it. Hence, there is a positive charge on oxygen. Later, in the presence of acid catalyst, as catalyst is taken in necessary amount, the H plus ion here, proton, will remove this hydrogen again to give the final product ester. Thank you.